In this video, we're going to learn how to solve these equations. So let's look at the first one. This is an exponential equation, and both sides are raised to a power here. So typically we take logarithms of both sides. The calculator I use only does direct logarithms in base 10 and base e. So either one would work, but I see here that the base is e. So I think what I'm going to do is I'm going to take natural logarithms of both sides. The next thing I'm going to do is use the power rule for logarithms, which says I can bring these powers out the front. So this becomes 4x times ln of e, and then I'll have x minus 2, don't forget to put it in parentheses, times ln of 4. Now of course the natural logarithm of e is just 1, because that's the longhand for it, and when the base and the argument are the same, that's equal to 1. So that's just going to be 4x times 1. And now I'm going to distribute the natural logarithm of 4 through here. I'm just going to do algebra, so this isn't a logarithm rule. So I have x times ln of 4 minus 2 times ln of 4. The next thing I want to do is get all of my x terms together on the same side. So I think I'm going to subtract that from both sides. And so that's going to go away. And I'm going to be left with that. Okay. Now, since I got everything with an x in it on one side, I'm going to factor it out. So if I factor, again, this is just algebra, not a log rule. If I factor out the x, I'm left with 4 minus ln of 4. And now to get x by itself, I just divide both sides by whatever it's multiplied by here. So those will cancel. And this is my exact answer. Okay. If you're asked to approximate to, say, 3 decimal places, then that's where a calculator would come in. So let me do that over here. And let's have a look at that. So I want negative 2 times ln of 4 in the numerator. And then I've got more than one term in the denominator. I need to put grouping symbols around that. So 4 minus ln of 4. Close the parenthesis on the 4, close the parenthesis on the entire denominator. Okay, if I take that to 3 places, that's going to give me that. And so what we could do now is go back up in here and plug that into x, and we should find that the two answers are very close, because don't forget we're taking an approximation there. Alright, let's go on to the next one. Okay, well, what I'm going to do now is I'm going to put these together into one logarithm using the quotient rule. Oh, that's the third one. Let's do that one first. I'm going to put these into one logarithm using the multiplication rule. So we have the same base, so I'll get a new logarithm, a single logarithm, and I do by multiplying these two together. Okay. So that was just using the rule. If you have log of a plus log of b and they both have the same base, they get combined in a times b. Okay, what I'm going to do next is change this, convert it into exponential form. And so what we do there is I'll have the base raised to whatever that number is, and equals everything that's in the argument. Okay, so I need to FOIL that, so I'll have 2 minus x minus 4x, and then plus 2x squared. Let's get everything on one side, so I'm going to subtract 5 from both sides. So I'm going to lead with my 2x squared term, Then I'm going to have minus x minus 4x is minus 5x. And then 2 minus 5 is negative 3. Now I could solve this by factoring this and seeing what the zeros are, or I could use quadratic formula. I think I'll use quadratic formula to get this. So a is 2, b is negative 5, and c is negative 3. So the quadratic formula says this will be equal to the negative of b plus or minus b squared minus 4 times a times c all over 2 times a. So I'll have positive 5 plus or minus. Negative 5 all squared is 25. These negative signs cancel. 8 times 3 is 24. And 25 and 24 is 49. This is starting to turn out nice. So I'll have 5 plus or minus 7 over 4. So I have two possibilities for x. I'll have 5 plus 7 over 4, which is 12 over 4, which is 3. Or I'll have 5 minus 7 over 4, which is minus a half. Now, what a lot of my students will do is they'll automatically reject that and say, oh, that's extraneous. Your answer's 3. No, no, no. You cannot take the log of something negative. You have to plug these into the original equation and see if you're taking the logarithm of something negative. To see whether or not it's allowed. You don't outright reject a possible solution because it's a negative number. So let's test 3. So if I plug 3 into here, I'm going to have 1 minus 2 times 3, and that's going to be, just that first term alone, is going to be 1 minus 6, which is negative 5. I can't do that. I can't take the logarithm of something negative. 3 does not work. And the reason 3 does not work is because when I plugged it into the original equation, I ended up taking the log of something negative. 3 is extraneous. Now what about negative 1/2? Well, let's see what that's going to be. That will be 1 minus 2 times negative 1/2. That'll be 1 plus 1. 1 plus 2 halves. Okay, and what about this term? If I plug negative 1/2 in for x, the base is 5. That'll be 2 plus a half, which will be 5 halves. And now I can put these two together using the multiplication rule into a single logarithm. And I'll have 2 times 5 halves. The 2's cancel. And I get that. And when the base and the argument are the same, you get the number 1. And that checks out. So I do have a solution. The solution is x is equal to negative 1 for this second problem. X is equal to negative 1/2. Or sometimes it'll write the solution like that. That's my solution for that second one. And finally, what about this one? Okay, I'm going to do them in the right order. Okay. Well, I think I'm going to put these together on this side using the quotient rule. And also, since I have a subtraction sign there, I'll put these two together into one logarithm using the quotient rule. Okay. Now, using the fundamental theorem of logarithms, if I have single logarithms on either side and they have the same base, then the arguments are the same. So these two quantities are the same. And I can just drop the logs. I can only do that if I have single logarithms on each side. So if I had a logarithm over here and just a number over here, I couldn't do that. I'd have to do a conversion. Now, how do I solve for x? Well, I think for this one I'm going to cross multiply, which means if I do that times that, it'll equal that times that. Okay, so if I do 2 times x plus 8, make sure you put it in parentheses, it will equal x times x plus 2. It's called cross multiplying. Now I need to expand this. Alright, now the 2x's will cancel, or you can subtract 2x from either side, from both sides. And now let me subtract 16 from both sides. But this is a difference of squares. And when you have a difference of squares, it will factor. So I can see that one solution is x equals -4, and another possible solution is x equals 4. Now I have to go back into the original equation and see if either one of them work. If I look at x equals -4, right there, if I plug in -4 into there, I'm taking the logarithm of something negative. So that's why I'm rejecting it. Not because x is a negative number per se. It's when I plug it into the original equation, I end up taking the logarithm of something negative. So that's extraneous. What about x equals 4? And what does this side give me? That side will give me that. And then if I use the quotient rule, I get that, and I'll get the logarithm, common logarithm of 2 on the left-hand side. Now what if I plug in x equals 4 on the right-hand side? I'll have 12, 4 plus 8 is 12, minus the logarithm of 4 plus 2 is 6, and then use the quotient rule to put those together. And I get common logarithm of 2 on the right-hand side. So left-hand side equals right-hand side, so they're the same. And so I do have a solution. My one solution here is x equals 4, or you might see it like that. And that ends this video.